Okay, so ulitin ko lang. The coverage for your exams. Ito yung mga coverage. Coverage ng midterm will be Newton's laws of motion. Um, work, energy, conservation. And last is yung center of mass, momentum, impulse, and collisions. Okay, so don't worry, hindi naman ganun kabibigat yung mga computations ito. Wala kayong ipoprove, wala kayong i-derive ng mga formulas. Ang gagawin nyo lang dito is problem solving, okay? So, your exam is mostly problem solving. Sulat natin yung specifications ng inyong exam. So, your exam will be 11 items. Nakikita yun, nakasulat. 11 items. Now, sa 11 items na yun, 5 of those will be Newton's laws of motion. So, 5 dito. 5 dito. Then, I have one question here, which is an essay question. Okay? So, you will be asked to make an essay dun sa last item. Not necessarily na mahabang-mahabang essay. Kahit 2 to 5 sentences lang. As long as ma-prove nyo at maabot nyo yung gusto nyo ipaabot na point. At kailangan makita ko yung point na pinaprove ninyo na yan. So this, this will be 20 points. So 4 points each yan. This will also be 20 points. So 4 points each din yun. So yung 1 to 10 will be a problem solving type of questions. So yung 1 to 10 na yan, 4 points each. So pag tama yung sagot, automatic 4 points. Okay? So alam niyo naman yung naging trend natin last time dun sa ating Schoology exam. So na maraming nagkamali sa inyo sa significant figures. I will not discuss that here kasi natakal na natin yun ng module 1. So it's up to you na kung paano nyo matatandaan yung significant figures. Pero applied pa rin yung concept natin for significant figures dito sa ating midterm exam. So yung last number, yung number 11, will be worth 10 points. Okay, so ibibigyan ko lang ng 10 points kapag nasagot ng tama yung question na tinatanong sa essay. And nabigyan ako ng proof kung bakit kayo nag-arrive dun sa inyong sagot na yun. So 10 points. So hindi guaranteed yung 10 points nyo kapag natama nyo lang yung sagot na kung ano may tinatanong doon. Kailangan makita ko din yung explanation ninyo and kailangan tama yung inyong explanation. You can use mathematical concepts, you can use all words, kayong bahala. Basta makita ko yung concept. So, pwede kayong mag-upload doon ng picture, pwede nyo i-upload doon yung, kung gusto nyo mag-illustrate, pwede. Walang problema. Okay, so simulan na natin yung ating discussion. So, ito ay review na lang. Alam nyo naman na last weeks, na-discuss na natin itong mga bagay na to. So, review na lang natin. So, review natin muna yung Newton's laws of motion. Laws of motion. So we have how many Newton's laws of motion? We have 3. Okay, so we have 3 laws. The first one will be the law of inertia. So hindi mahalaga itong mga definitions kasi hindi ako nagpapadefine. Hindi natin kailangan ng mga definitions sa exam sa physics. We are more of application. So kailangan problem solving tayo. Pero i-discuss na rin natin si law of inertia. Anong sinasabi ni law of inertia? Law of inertia states that a moving object or an object at rest will stay in motion or at rest unless acted upon by an outside force. So yun lang, law of inertia. Yung isang bagay daw ay gagalaw or patuloy siyang gagalaw kapag hanggat walang nag-act sa kanyang outside force. Or kapag hindi naman siya gumagalaw or nasa rest siya, an object will stay at rest hanggat walang gumagalaw sa kanya. That is the law of inertia. Now, the second law is just the mathematical presentation or representation of the first law, which is net force or F sub net is equal to mass times acceleration. Okay, so net force is equal to mass times acceleration. Alam niyo naman na yan. The force or the net force applied on an object is equal to the mass times its acceleration, or FMA. Now, for the third law, we have the law of action-reaction, or action and reaction. So, ano sinasabi ng law of action-reaction? Ang sinasabi ng law of action-reaction, if you exert a force towards an object, the object will exert an equal and opposite force in return. So, yun, kung pag na-exert ka ng action, may expect kang reaction. So, meron din siyang mathematical representation. Meron tayong F sub 1 is equal to negative F sub 2. Or, yung F sub 1 dito is yung iyong force applied. Yung negative F sub 2 is the negative force. So, ibig sabihin, it is going towards the opposite direction nung in-apply mong force. So, yan yung ating 3 laws of motion. Now, let us differentiate mass and weight. So, hindi naman kasama to sa exam, pero it's nice to know and must know siya. So, mass and weight, ulitin natin, mass is, SI unit niya is kilogram, kg. Yung weight natin, this is mass times the pull of gravity. So, yung G dito is gravitational pull. This varies kung nasaan ka. So, sa Earth, ang gravitational pull natin is 9.8 meters per second squared. So, acceleration siya, kaya meters per second squared. Okay? So, that is the difference between mass and weight. Yung weight natin, ang SI unit niya is in newtons. Same is true with force. So, force, ang SI unit is newtons. So, hindi nyo na kailangan ilagay yung unit sa, nakalagay na dun yung units, you will input only the mathematical or the numerical values. Liwanag tayo doon. Thumbs up kung naintindihan. Okay, thumbs up. Sige. Lista nyo muna yung mga questions nyo sa 4 sats. Babalikan natin siya mamaya. Okay, para tuloy-tuloy yung ating discussion. Now, let us discuss yung free body diagram. Ito, magagamit niyo itong concept na to sa paggawa ninyo ng big pitas kung hindi pa kayo nagpapasa. Okay. So, free body diagrams. Ano ulit si free body diagrams? They are used to denote or to show the relationships between certain applied forces. So FBD or free body diagrams. So these are used, ulitin ko, these are used to show representation na mga forces applied or forces acting upon an object. So for example, meron akong, ang tawag natin dito is, it's either the object. Narinig ba ako malinaw or may mga narinig kayong tahulakas? Ang tawag dito is object or system of interest. Okay? So sa big pitas niyo yung system of interest is yung ball lang, ha? Hindi yung basketball player. Okay? So system of interest natin, ayan yung object. Okay? So for example, kapag the object is lying on the ground, therefore, we have a normal force acting upon that object. Okay? So ang normal force natin is going upwards palagi kapag naglalay siya sa ground. So this is our normal force. Then, yung nagpupull sa kanya pababa, that is our weight force, which is equivalent to, ulitin ko lang ang formula, mass times pull of gravity. This is in terms of vertical orientation. Kapag naman the object is being pushed, for example, horizontally, so horizontal ang push natin. So, pag horizontal, it's either left or right, so along the x-axis. So, meron tayong mga factors dyan. Ayan yung mga tinatawag natin external forces. So, we have, for example, kapag the object is suspended in the air, ang external force natin doon is air resistance. Okay? Kapag suspended siya sa air. So, ibig sabihin, nasa free falling siya or suspended sa air. So meron tayong air resistance. Kapag it's lying on the surface naman, we have friction. Okay, so for example, sinabi natin to lying lang on the ground. So for example, nag-apply ako ng force going to the right. So yung free body diagram natin, may a force applied or F sub up or sige F na lang ilagay natin. Ang opposite force na nag-act dyan is our friction kasi lying on the ground. So may friction yan. We have kinetic and static friction. Okay? So kinetic friction, ulitin ko lang, kinetic kinetic friction. Kinetic friction is friction in motion. Ang formula for kinetic friction is F sub K is equal to mu sub K times the normal force. Okay? So for static friction naman, this is friction at rest. So we have F sub S is less than or equal to mu sub S. This is coefficient of static friction times the normal force. Okay? So that is, and dagdag natin yung sa force. So sa free body diagram, ginagamit natin nga siya sa pag-illustrate ng mga forces applied upon an object. Ginagamit din natin siya para mas madali nating maipag-represent yung ating mga forces. For example, I have normal force ulit. I have dito naman weight force, tapos meron akong force applied. Then meron akong frictional force. So yung F-net natin dito, F-net again is the sum of all forces. So along the x-axis yan or F-net x, i-add mo lang lahat ng mga forces in the x-axis. So ano mga forces dyan? We have positive F. And yung frictional force natin is always going in the opposite direction. So siya ay negative. So yung F-net x natin dito is applied force minus frictional force. Okay? So hindi all the time equal yung frictional force sa applied force. Okay? So kapag ang F-net y naman, in terms of y, net force in terms of y, i-add lang natin ulit yung mga forces applied. So anong forces applied dito? I have a positive normal force, F sub n, minus yung nagpo-pull down sa kanya na weight. So may mga times na normal force is equal to the weight. Actually, all the time yan. So yung net force in terms of y is 0 kasi equivalent yung dalawa. This applies kapag the object is at rest or hindi siya gumagalaw along the y-axis. Okay? So ulitin ko lang yung net force is the summation of or sum of all forces. Depende yon kung anong axis ha. Kasi sabi doon sa module 3 natin, if I remember correctly, yung independence of our vector values or module number 2 ata. We can represent a vector in terms of its x and y components. So pwede siyang ipaghiwalay. Now let's move on with work, energy, and energy conservation. But before we proceed, ulitin lang natin yung discussion for dot product. Okay, hindi ko na ulit sinama si dot product kasi mahirap magpa-assess sa Schoology kapag magpapa-illustrate ka. Okay, so si dot product, it is also called scalar product. Bakit siya scalar product? Kasi scalar yung lalabas ng product. Pero it is a multiplication among vectors. Okay, multiplication of magnitudes of vector quantities. Medyo mabilis ba? Sabihin nyo kaagad kung medyo mabilis ha, para bilisan pa natin ulit. Joke lang. Para mag-adjust tayo ng konti. Slight lang. Okay? So yung dot product natin, ang illustration will be, I have two vectors and there is an angle formed in between. So I have, for example, vector A and vector B. The dot product of vector A and B is represented as A. dot B, okay, is equivalent to the product of the magnitude of vector A times the magnitude of vector B times cosine of the angle in between them. Okay? So, bakit natin diniscuss ulit si dot product? Kasi same formula or same concept ang ginagamit natin for work. Okay? So, now, let's proceed with work. So work is transfer of energy. Okay? So, work, anong formula for work? We have W, capital letter W. Work is equal to FD, or force times the displacement of the object. Displacement. This is our force. Okay. Force applied. This is our work. No. Okay. So, yan ang ating general formula kapag walang angle in between force and displacement. Paano naman, sir, kapag may angle in between? We will use the concept of dot product. Therefore, we will yield a result of the dot product will be our work. So, therefore, ang work natin is a scalar quantity. So, work will be the magnitude of F times the magnitude of D times the cosine of their angle in between. Or simply, work is equal to FD cosine theta. This is used kapag meron tayong angle in between. So, ibig sabihin, kapag ang given natin is a force is applied at an angle, sinasabi naman yon, or may makikita kayong angle theta is equal to ganito. Okay? Sasabihin naman yon sa problem. Okay? So, that is work. So, we have 4 cases. Ano ulit yung mga 4 cases natin? Actually, hindi ko na pina-identify ko anong case kasi ako lang ang gumawa ng cases na yun para mas madali lang nating maintindihan. Actually, wala siya sa books. So, ang case 1 natin, kapag the force is being applied at an angle. So, this is, ang gagamit nating formula, work will be FD cosine theta. Ang case 2 naman, kapag a force being applied is an obtuse angle. So, angle theta ito. Kasi pagpasensyahan nyo na. Wala pa rin akong whiteboard kasi hindi pa rin nakaisa bahay. So, work applied here will be negative FD cosine theta. And case number 3 natin, kapag ang force applied are parallel. So, it's either F and D or going upwards F and D. So, kapag parallel siya, we will use the formula work is equal to FD. Yan lang. And case number 4, kapag perpendicular yung ating mga vector quantities, ang magiging formula, work is equivalent to 0. Therefore, no work is done. Okay? So, maging familiar lang kayo. Basahin nyo lang maigi si problem. Try nyo illustrate si problem. Illustrate nyo kanyang free body diagram para makita nyo kung anong case yung gagamitin ninyo. Okay? So, those are the 4 cases of work. Now, let's move with energy. So, energy, paano sinusukat si energy? We have potential and kinetic energy also. We also have the network energy theorem. So, ano sinasabi ng network energy theorem? The network or W sub net is equal to the force net or net force times the displacement. Okay, so alam natin yung equivalent nito, F net. This is our second law of Newton. F net is equal to M A. So, we can substitute W net is equal to MAD. Okay, so that is the formula for the one formula for network. Another formula for network will be using the acceleration and kinematics network. Tatandaan ninyo, we use different formulas depending sa ating mga givens. Okay? So, M times Vf squared minus Vo squared all over 2D times D, or we have 1/2 mvf squared minus 1/2 mvo squared. So we use this formula if ang given natin is initial and final velocities and we're finding for the net work. Okay? And as we all know, the formula for kinetic energy is equal to 1/2 mv squared. And for potential energy, we have, this is potential energy due to gravity, mgh. Whereas m is the mass, g is our pull of gravity ulit. Pull of gravity. So that is a constant depending on wherever you are. So height, this is the height of the object. Okay? So those are the formulas we need for work and energy. Now for power. So wait lang, ulitin natin. Ang SI unit for work is in joules, okay? So SI unit for work is joules or capital J or Newton meter. Okay? So now we proceed with work. Thumbs up kung naiintindihan pa so far. Alam niyo naman yan. Ni-review lang natin na mabilis na mabilis. Okay, now let's proceed with power. So power, this is the rate at which work is done or rate of work. So we have the general formula, capital letter P is equal to work over time. So ang kanyang SI unit for power is in watts. Okay? Or capital letter W. Or which is equivalent to joules per second. So yan, yung power. Okay? So pag tinanong kayo, for example, I have a 25 watt bulb. How much work is done in 1 second? Oh. So paano 'yon? Power is equal to work over time. So ang given natin is 1 second and 25 watts. So I have 25 watts is equivalent to work over 1 second and multiply both sides by 1 second. This will cancel. This is joules per second, di ba? So magka-cancel yan. May matitira kang joules dyan. So I have 25 joules is equal to the work exerted. So ganun lang siya. Actually, same type of question will ang lalabas sa inyong exam pero different given. Now we have energy consumption. Okay, energy consumption, it is the rate at which energy is consumed. So ang kanyang formula is capital letter E is equivalent to power times time. So ang kanyang SI unit niya is watt seconds. Pero ang mas familiar tayo is kilowatt hour. Okay? So yan lang si energy consumption. Questions tayo sa work, energy, and energy conservation so far. Thumbs up ko naiintindihan pa so far. Wala na nagta-thumbs up. Wala na nakakaintindi. Okay, so those are the 3 types of the center of mass. Okay, so now let's proceed with momentum. Momentum is inertia in motion. Okay, momentum. Okay. Now let's proceed with momentum. Hindi naman mahalaga yung mga definitions. Basta alam nyo kung ano yung mga ibig sabihin lang niya. Kasi hindi naman ako nagpapadefine sa physics. So, momentum is quantity of motion. It is denoted as small letter p. Okay, lowercase p. Ang kanyang formula, p is equal to m. V, ang kanyang unit, hindi siya SI. It is kilogram meters per second. Okay, so yan yung unit niya. unit for momentum is kilogram meters per second. So now, paano pinresent ni Newton yung kanyang second law? 'Di ba sinabi doon na hindi talaga yung F net is equal to MA yung sinulat niya sa book, kundi F net or the net force is equal to the change in momentum over change in time. Ganyan niya sinulat yun sa kanyang aklat. Okay? So, if mo-manipulate natin yan, lalabas tayo sa formula ng impulse. Ano ulit yung formula ng impulse? Impulse is change in momentum. Ang formula for impulse is F net delta T. So, ulitin ko lang, impulse is change in momentum. So, pag sinabing change in momentum, our change in momentum is equal to change in mass times velocity. Pero kapag constant yung mass, sinasabi natin na change in momentum is equal to mass times change in velocity. So, pag sinubstitute natin yon dito, mayroon tayong lalabas na F net is equal to M delta V over delta T. And as we all know, delta V over delta T is equivalent to A. Kaya babalik tayo sa formula ng second law, which is MA. Okay? So, yun lang yung proving kung paano nag-arrive si Newton sa kanyang law of motion. Okay? So, we have covered momentum and impulse ng sabay. Now, let us discuss law of conservation of momentum. Sinasabi ng law of conservation of momentum, teka, bakin ko lang, that momentum is conserved, just like energy. Energy is conserved also. Yung sinasabi lang kapag sinabi nating conserved, sinasabi lang dito na sum ng input, summation yan. Summation yan. Summation ng input is equivalent to summation ng output. Or input is equivalent to the output. Yan yung sinasabi ng conserved. So, sinasabi ng law of conservation of momentum, law of conservation of momentum, that P sub 1 plus P sub 2 is equivalent to P sub 1 prime plus P sub 2 prime. Yung input momentum is equivalent to the output momentum. Thus, papasok tayo sa collisions. Ito din ang formula for collisions.
Ano kami? Magka-call. Kasi pag magsasagot, lagi kami magka-call. Sorry po.
Okay. Okay, so this is also the formula for collision. Ginagamit din natin yan. Or we also use the formula for yung internal kinetic energy. So natatandaan nyo pa, sorry. Internal kinetic energy, sinasabi lang ng internal kinetic energy, sum of all KEs. Or sum of all kinetic energies. Hindi na nababasa S. Yan. So, we have two types of collision ulit. We have elastic and inelastic. So, for elastic collision, ang kanyang formula, KE is equivalent to KE prime. Okay, so, conserve yung kinetic energies natin. Dito naman, KE, before collision is equivalent to mv squared. And kinetic energy prime is equivalent to 0. This is for inelastic. Ulitin ko lang, sa elastic, there is motion after collision. Motion after collision. Sa inelastic, nagdikit sila. Okay? They stick together. Okay, yeah. So that ends my part. Okay, my part discussion. So I will now entertain questions. Yeah. You can turn on your cameras para nakikita ko naman kayo. Sulat ko na lang diretso yung given. Okay? So, ang sabi dito, suppose a 30 kilogram. And suppose a 30 kilogram package on a roller belt conveyor system is moving at, this is our mass, is moving at 0.500 meters per second. What is its kinetic energy? So, ang hinahanap natin is KE. Formula for KE, we have 1/2 mv squared. So, we substitute the values. I have KE is equivalent to 1/2 times 30 kg times 0.500 meters per second. Now, using your calculators, ang lalabas nating
Sir
sagot.
square.
Sorry. Thank you, Chester.
3 point, ano sir? 3.75.
5 squared.
Ano yun sir? Joules? Okay.
Kinetic energy is in
Joules.
joules. Energy. Divided by 2. So, 3.75. Ilang significant figures, Teo?
Ewan. Tatlo.
Galing.
Tatlo.
Tatlong significant figures. Okay, so tama lang sagot natin na 3.75. Okay, isa pa. Sa work naman. Tama tayo.
Sir
Okay,
JC,
ito.
pag pumasa ako dito, di ka na ba-alis?
Okay, ito na yung given. Yes.
30% to, di ba? Kasi ano.
30.
Ano ba yung grading system mo?
Okay, ito na. So, yung given natin, I have a 75 kilogram person. So, ito yung mass niya. Tapos, umakyat daw siya ng stairs. Tapos, yung height ng stairs is, or yung displacement niya is 2.5 meters. Linawan natin yan. 2.50 meters. Okay, so ang hinahanap is yung work done. So now, how do we compute for work? Anong formula ang gagamitin natin?
Kukunin muna yung force, baka.
Yes, kukunin natin yung force. Paano natin kukunin yung force?
Titingin sa papel ng katabi.
Wala kayong katabi.
Mass
Okay,
times
so pwede-
gravity, sir.
Mass times gravity. Kukunin natin yung weight niya, kumbaga. Kasi yung weight niya is yung force applied niya. Okay? So, kunin mo natin yung small letter W, which is mg. So, W is equal to the force then applied. So, FAPP. So, weight is equivalent to 75.0 times 9.8. Sabihin natin nasa Earth siya kasi may stairs sa Earth. So, ang lalabas dito, weight niya is in newtons. 75 times 735 newtons. Now we have the force applied. Madali lang din yung tanong bukas, Reg. Huwag kang matakot. Now we can substitute to the formula, WD. Now work is equivalent to 735 newtons times.
Okay lang yun, sir. Double yung gamitin.
Weight kasi yung ginamit natin. Equivalent
Pwede
naman
yun,
siya
sir.
sa force applied.
Okay. Okay ko.
So times 2.5 meters. Now, ang sagot natin will be in joules. 735 times 2.5. Teo, anong sagot? Ilang significant figures?
Tatlo.
So, ang may sagot natin is 184.
184. Ay, 1,840.
1,840 joules.
Joules. Grabe, March yan.
Okay, Teo, nakuha.
Walang mas mahirap dyan, sir.
Ganyan ang kadali yung exam nyo.
Sige, sir. Perfect ko na agad. Lagay nyo na sa class record.
Yung given natin, sulat ko lang yung given. Calculate the momentum. So, ang hinahanap natin is small letter P. Of A, ang mass niya is 110 kilogram player. Football player. Running at 8.00 meters per second. So, yung given natin is its velocity. Meters per second. Okay? So, ano yung magiging sagot natin dito? Ang formula for momentum is P is equal to M. V.
MB.
Okay? So, substituting, we will have, now I have P is equivalent to 110 kilograms times 8.00 meters per second.
880 kgms.
Now our momentum is 880 kg m per second. Yan lang. That is for
May
momentum.
May tanong ako. Bakit P?
Bakit?
Bakit P yung symbol ng momentum?
Actually, hindi ko din alam. Teka. Now, for force, at yung given natin, a physics professor pushes a cart. So, push. Okay, i-emphasize natin yung push. Pushes a cart so towards the positive direction yan. Of a demonstration equipment to a lecture hall, her mass is 65 kilograms. Mass ito ng professor ha, mass ng professor. The cart, yung mass ng cart is 12 kilograms. This is mass ng cart. Ito yung pinupush niya. Tapos mass ng equipment is 7.0 kilograms. So, iba-iba yan. Okay? Iba-iba yung mass niya. So, yung mass ng professor, ulitin ko, is 65. Yung mass ng cart is 12. Yung mass ng equipment is 7. Calculate the acceleration. Hindi, huwag natin pa-copy yung sarili natin. Calculate the force applied. Force applied na lang no total. So, force total na lang. Paano natin ko-compute? Sabihin natin na yung kanilang acceleration is, sabihin natin 5.0 meters per second. Now, how do we compute for that? We can either use the formulas for individual. So, pwede natin hanapin yung force applied nito, tapos force applied nito, tapos ipag-add lang natin. Bakit sila po pwedeng ipag-add? Okay, tingnan natin. So, FBD niya, dahil nasa surface, meron tayong normal force, meron tayong weight force. Meron kang applied force na, ito yung sa teacher. May applied force ka pa nung nasa cart. Tapos may applied force ka pa nung nasa equipment. Okay, so neglecting friction. So ibig sabihin, walang frictional force na nag-act pabalik. So lahat ng force natin along the x-axis is ipag-add lang. So walang frictional force. So paano yun? Pwede natin gamitin na F applied or F total is equivalent to add mo lahat ng masses. So 65 plus 12 plus 7. Tapos multiply mo sa acceleration. Or, pwede mo silang individual. 6.5 times 5, same lang din naman yun by distributive property of multiplication over addition. So, computing, for the force applied, we have 65 plus 12 plus 7 times 5. We have 420. Anong unit natin for force? We have newtons. So, ito yung total. So, pag for example, hinahanap lang yung force applied nung cart, ito yung cart lang yung gagamitan mo ng mass. Pero ito is yung total. So, lahat sila taking consideration yung mass ng professor, yung mass ng cart, and yung mass ng equipment. So, ito ay summation of all masses times yung acceleration. Pwede din naman na mass acceleration ng una, mass acceleration ng pangalawa, and mass acceleration ng pangatlo. Pares lang naman lalabas dyan. Kasi ito, using distributive property, we have, baliktad pala, yung mass pala dito yung magkakaiba, hindi acceleration. Ito, mass nung una, mass nung pangalawa, mass nung pangatlo. So, using distributive, or if factor out natin, I have acceleration times mass 1 plus mass 2 plus mass 3. Same din dito. Ito yun. Okay? Kuha. Sagot natin is 420 newtons. Natandaan nyo kapag nakalagay neglecting friction, yung net force natin along the x-axis will be equivalent to the applied force. Kapag may friction, di ba, ang net force natin is isubtract mo yung frictional force. Okay?